Hello and welcome back to Spoken Essays. I am Harshal Vora and you're watching the live video. So let's see what we were up to last time and let's begin or continue from what we were doing. Just a second, I have to turn the light on and switch the lights. And I'll also connect the charger. You know what? Why don't you guys look at that? Yep, okay. Just a second, I'll be right back. I'll be back. Okay, let's see what I was up to before. Okay, so that's the music. All right. All right. Okay. One day I will also tell you why I say all right. You know what? I'm going to hard refresh this page. So yeah, just in case, so that we are good to go. And don't worry guys, I'll also show you how to do this locally after I finish this step, this project. It takes a few minutes to start the virtual server. In the meanwhile, I'll also do one thing. Need to clear the cache. I'll refresh the page actually. Yeah. You know what? Hosted app data. Exactly. I need to clear all of that. Not the cookies really. Download history to cache and hosted app data. The app data must be, it's from web store, must be from one of these guys. Anyway, so cache has been cleared. I'll refresh this page again. Cool. Let's begin. We'll have to wait for the editor to launch. In the meanwhile, I'll go full screen. Yeah. To avoid all of this, in the next part, after I'm done with this segment, when we go to the next project, I will do something else. I use VS Code and try to do this locally. You'll have to wait a few seconds, a few minutes at the least. I can close this. Let's wait for code road to load. Cool. I'll also open the previous terminal. In here we will see 2 terminal entries. No, we do not. I do not. No problem. Must be because of the history. Not a problem. So I'll have to look for that again. So Postgres SQL. The username is freeCodeCamp, and the database name is Postgres. Wait, fatal database Postgres. Postgres, yep. Now we are inside Postgres. We connect to our database called, what's it called? To know which database we are working on, let's list them. We are working on Mario database, yes. So connect to Mario underscore database semicolon, enter. We are now connected to Mario database. Cool. L please, so it can list me. Okay, right. And databases, so we have 4 databases now. Okay, what happened to the third database? I think I should reset this. What happened to the actions database? Can't see actions here. Oh, some of our progress was missed here, that's why. So if I write D here, it will only, okay, now it does show us actions and sounds and whatnot. Very good. Okay, so the action table won't have any foreign keys. It's going to have many-to-many relationship with the characters table. Yep, not one-to-many. This is because many of the characters can perform many actions. Yes, you will see why you don't need a foreign key later. Insert a row into the actions table, give it an action of run. Okay, so insert a row, right? So insert into, what's it called, actions. So in actions we write values, inside the values and the semicolon 2. Before I do that, I need to understand what what columns actions has. So I'll use select and from actions semicolon, I'll press a space and a asterisk to see. So we have action ID and action itself. Very good. Anyway, okay, so that's what it is. So now insert into and values, insert into actions, and what values will we give it? So give it an action of run. So we first, I think the ID is not null, so if I just write null here, it will work. Nope, it had a problem, data type problem. Not a problem. I mean, that's not a problem. We'll put 1 here for the index value, and it has been inserted, and we can go to the next step. Now insert another row into the actions table. Another row means another ID. You will be called jump. So someone can jump, someone can dance, whatever, etc, etc. Cool. Next, another action called duck. कुछ भी कचरा आ जाता रहता है. Of course jump exists. Sorry about that. I shouldn't have lost my temper. I know it already exists, my friend. Fine, I'll type it. ins bro press, I can't press. ये क्या है? Insert allow insert into actions values, what is it, 3 comma space duck flows and semicolon. Done. Yeah, I just hope we pass this. Yeah, only 16 more percent left. Will almost be done with this. Okay, view all the action data in actions. So select from actions. So now we have run duck, jump and duck. It looks good. Many to many relationships usually use a junction table to link two tables together, forming one to many relationships. One to many. So what it means is Mario can also use duck, run and jump, as well as the other characters Luigi and Peach and whoever, I mean Yoshi too. Anyway, it looks good, right? Your characters and actions table will be linked using a junction table. Create a new table called character actions. Cool. Create table character underscore actions semicolon. Oh yeah, parentheses, I almost forgot. Done. The table has been created. Your junction table will use the primary keys from the character's actions tables as foreign keys to create the relationship. Add a column named character ID to your junction table. Alter table character underscore actions. What do you want? Add a column. Add column character underscore ID, type of integer and constraint of not null. Done. The foreign keys you set before were added when you created the column. Yes, you can set an existing column as a foreign key like this. Thank you. Set the character ID column you just added as a foreign key. Yep. Table name character underscore actions, add REIGN characters. Is it characters? Yeah, characters. And your reference. Hello? References will be characters. They should actually be characters underscore. Let's just get this over with. अब क्या है? I think this should have been what is this? बे यार, I swear. Let's just finish this. I could also have reset the test for this. Come on. The older one, finally. Are you still stuck? Finally, okay. ALTER TABLE table name will be character ACTIONS space add FOREIGN set character ID column CHA action underscore ID. Are my keystrokes too fast for you, my friend? Referenced table will be set the character ID column you just added as a foreign key that references the character ID from the characters table. Wait, set the character ID column you just added as a foreign key. यहाँ पे क्या था? एरर एट और नियर लाइन वन और वेरिएबल एट अच्छा फॉरेन के बाद की लगाना था। ये हाँ, आय हाय हाय हाय। I will be extremely careful. Space capital A D D space FOREIGN space KEY bracket lowercase CHARACTER underscore ID bracket close space REFERENCES space CHARACTERS bracket open CHARACTERS nope only character underscore id bracket close semicolon plus error. Character actions does not exist. Reset the tutorial. Character actions does exist. Yup. Altered. And we pass the test. Next, view the details of character actions. Select asterisk from yeah, but they wanted to see the details, right? Yep, foreign key constraints are here. Next, please add another column to character underscore actions. New column ALTERTABLE character underscore ACTIONS. That's the name of the table. Add column space action underscore id. Type is integer and its constraint is not null. Semicolon, enter. It has been altered. This will be a foreign key as well. Set the action id column you just added as a foreign key that references action id column from the actions table. Very cool. No. Baapre. I did not want to type that. Connect to Mario database. हाँ क्या करना था action ID right alter table what's it called I need to list the tables again sheesh we have character actions right alter table actions अला यार अला character actions क्या करना है फॉरेन की सेट करनी है ना आउच that's what you do huh okay. Review please कहाँ गया फॉरेन की it will be at the end thank you हाँ add foreign key, we're supposed to add action underscore id references. Reference table would be actions and the id will be action underscore id, the same as that, semicolon at the end, enter. It has been altered. Next, view the details of the character actions table to view your keys. Okay, it's a view the table, right? Yep, we now have two foreign keys and we have two columns, character id and action id. So that's how we are mapping this data. Next, I am seeing the keys action id and character id. Okay, every table should have a primary key. Your previous table had a single column as a primary key. This one will be different. You can create a primary key from two columns known as a composite primary key. Here is an example. Primary key, inside key we write column 1 and column 2. Cool. Alter table character underscore actions space add क्या था, primary key, column 1 would be this and column 1 would be that. So we write character underscore id comma space action underscore id bracket close semicolon ended. Table has been altered. If we run the test, we will pass it, and we are 89% complete, 90% finished. What that would be, I think, yeah, 15 more to go. करते हो जाएगा, don't worry. This table will have multiple rows with the same character ID. Multiple rows the same action ID. So neither of them are unique, but you will never have the same character ID and action ID in a single row. It will be different combinations. One character will have 3 actions. So each character 3 actions. We have 7 characters and 3 actions. So we will have 21 entries. In multiple rows the same action ID. Yeah. So neither of them are unique, but you will never have the same. Yeah. So the two columns together can be used to uniquely identify each row. View the details of character actions table to see your composite key. As seen here, this is our composite key. Yep, 2 of them are primary keys now. Yeah. Next, insert 3 rows into character actions for all the actions Yoshi can perform. Very good. This will help us. Yeah. Insert करना ना. Insert into character actions values first value क्या चाहिए. अच्छा हने. Okay, Yoshi. That means I need to remember the number Yoshi has. So first we need to select everything from characters to see. Okay, Yoshi's number is 7. So the first value will be 7 for 3 actions, and action ID will be 1. He can perform all of them in the actions table. Insert 3 rows into all the actions. Cool. View the data in characters and actions table to find the correct IDs for the information. I think we don't need to do that. We will still pass the test anyway, because I know all the actions. We have 3 actions, 1, 2 and 3. Action ID. I only needed the character ID, so now I have it. 7. Cool. View all the data in character actions to see your rows. We don't need to do that though, because we already have this, but fine if you say so. Select asterisk from character actions. Yep, the first column is character ID and the second column is action ID. Next please. Add 3 more rows into character actions. Finally. Hi. ये क्या है? How did that even appear? Fine, whatever. Press enter please. Very good. Right. Now we can start inserting. Insert into character actions values. Okay, first is the character ID, which is 7 for Yoshi. What, you want to do it for Daisy apparently? Kyala 6. Action will be 1, comma space. Add 3 more rows into character. She can perform all of the actions as well. We didn't give any actions for Yoshi though. So yeah, ठीक है, whatever. Can I pass this test without writing anything? Even if I write this much, even if I don't. Oh bro, this is a glitch. अभी तो मैंने पास भी नहीं किया project को. Ouch. Fine, I'll write it though. 6 comma space 2 comma bracket open, 6 comma space 3 bracket close, semicolon. Done. Yeah, we've already passed it anyway. Browser can perform. Yeah, so we're doing that for all of them. I'm going to reset the lesson so that I'll also see, not only do I see, the actions of the one I missed, Yoshi, but yeah, cool. So you say actually not this. Select please. I know. Right, we have 777 and 666 exactly. Bowser, what number is Bowser? 5. Cool. Done. Almost done, guys, don't worry. Once I'm done with this, we'll do this locally. Yeah, it will be faster locally because it will be the computer's computing power and not the Chrome browser's computing power, nor the virtual machine's computing power, because it's far. Coffee. So Now we play with the toad. Toad is 4. I'm so in love with you. Whatever you want to do is alright with me. 'Cause you make me feel so brand new. I want to spend my life with you. And they say since, baby, since we've been together, ooh, loving you forever is what I need. Let me be the one you come running to. I'll never be untrue. Ooh, baby, let's stay together, loving you whether times are good or bad, happy or sad. Whether times are good or bad, happy or sad, find somebody. Find people and break up, turn around and make up. I just came to see, 'cause you never do that to me. Oh baby, still all around you is all I see, is what I want you. You want to stay together. 96% complete. Loving you whether times good or bad, and happy or sad. Okay, well done. The database is complete for now. Take a look around to see what you ended up with. First, display all the tables you created. Yep. D for displaying all the tables that we've created. As you can see here, we have actions, characters, more info and sounds, and the ID sequences as well. So 9 rows are in this. Next, there's 5 tables there. Yep. Actions, character actions. Character actions does not have a ID sequence because the sequence need not be mentioned. It's all foreign key really. Nice job. Next take a look at all the data in the characters table. All the data. When they say all the data, they mean select from. Come on. CHARACTEERS. Yup. Those are some lovely characters. Yup. View all the data in more info table now. Yep. we have their birthdays, fake birthdays or whatever, height in centimeter, weight in kg, character IDs and whatnot, more info ID as well. Next. Yeah, I think they're just stalling now. 90% complete. Wow. Okay, something new now. You can see the character ID there, so you just need to find the matching ID in the characters table to find out who it's for, or you added that as a foreign key, which means you can get all the data from both sides with a join command. Very good. So now we're learning join. Join command is used this way. Enter a join command to see all the info from both tables. The two tables are characters and more info. Okay, so that's where we're getting data from. The columns are character ID column from both the tables, since those are the linked keys. Yep, they are. Okay, so we write select columns character underscore ID from table 1 would be characters, then full, then join, then the table number 2, which is more underscore info space on characters dot primary key column is character underscore ID equals table more info dot that's also character ID actually. Wait, think. Why did we not use birthday? Who knows? Foreign key column. The foreign key is character ID. This is the primary key, which is character ID, and the foreign key here is character ID as well. I made a mistake somewhere then. Select character underscore ID from characters, then full join more info on table 1, which is characters dot character underscore ID equals table 2, which is more info dot characters underscore ID. Column reference character ID is ambiguous. Bro, it is what it is. What do you mean ambiguous? Let's check again. Select columns I must not have written this correctly then. Select columns. The columns are character ID column from both tables, since those are linked keys. So select character ID CHARACTER from table number 1, which is characters, then full join, then table number 2, which is more underscore info on first table number 1, which is characters dot character underscore ID, and equals table number 2, which is more underscore info dot character underscore ID. Let's look at the hint then. Give it one more try, read closely. Without the keywords, it looks like this. Characters more underscore info, characters dot character dot ID, more info dot characters. Exactly. I did this. Select asterisk from. अच्छा ऐसा. That's why it's ambiguous. Oh. Because you want to look at all of them. I see. Now I can see character ID, name, homeland, favorite color, their birthday, height in centimeter, weight in kg, and character ID again. So now we can see everything from two columns, two tables. Yeah, almost done. Now you can see all the info. Yep, if you recall, this is a one-to-one relationship. So there is one row in each table that matches a row from the other. Use another joint command to view the characters and sounds together. They both use the character ID column for their keys as well. Yep, as expected. SOUNDS. Sounds again. Done. As you can see here now, sound ID and its file name are also mentioned here. Daisy, Toad and Yoshi do not have any sounds, it seems. No, they do not. Second yawn. Don't worry, I'll be with you guys, don't worry. थोड़ा कॉफ़ी वॉफ़ी पी लूँगा तो नींद चली जाएगी. This shows the one-to-many relationship. You can see that some of the characters have more than one row because they have many sounds. Yes. Mario 2 entries, Luigi 2 entries, Peach 2 entries, 3 entries, Mario another entry. So Mario 3 entries, Luigi 2 entries, Peach 3 entries. The rest do not have any sound, so they are only mentioned once. Congratulations on making it this excellent. Baki, how can you see all the info from the characters actions and character actions tables? Here's an example that joins 3 tables. Select columns from junction table. Full join table 1, full join table 2 on this. Cool. Congratulations on making it this far. This is the last step. Yup. View all the data from characters actions and character actions by joining all 3 tables. When you see the data, be sure to check the many-to-many relationship. Many characters will have many actions. Yup. I shall do it. Okay, we will type this now. Select asterisk from, what will the junction table be called? I don't know. For that I need a hint. Use character ID column to join character actions and character. I know that, but okay, fine. Full join table number 1 is character underscore actions. Then first actions or first, ठीक है पहले actions लिख देते हैं. Full join actions on junction table, which is characters dot foreign key. This is incorrect. Use character ID column to join character actions and characters. Use action ID column to join. Okay. First will be character actions. What? Acha, that's what you're connecting. Junction table. Character actions full join characters on character actions dot character underscore ID. Yeah, makes sense. Equals characters dot character underscore ID. Then full join actions on run actions on character underscore actions dot action underscore id equals actions dot action underscore id semicolon close enter. Yep, we see it. Yoshi from Dinosaur Land, who has this, can run, jump, duck. Nicely done. Oh, apparently there's one thing else. No, nope, we are done. Congratulations, thank you. That means if I open this in a new tab, the progress shall say, it is 28th July. Now we have 2 points because I finished 2 things. Yay! Cool. I can't open any new workspaces because there aren't any. This is all inside this. Git VS Code run relation. Yeah, we are done with this. Anyway, ठीक है, इसको बंद करो. We file close editor. It won't close itself. Yeah. Yeah, I know. Relational database. Now we are also done building a Mario database. Now before I begin with new celestial bodies database, I'm going to open this forum and try to understand how we can do this locally. Otherwise I'm going to lose it. But before I get started, I'm going to take a short break. That was exhausting, I should say. Even if I started only 40 minutes ago, this thing is taxing. So let me take a short break. When I come back, I will continue with this. Thank you. Okay, so I'm going to do it the local way. Allah. No. I cannot earn my certification. Ouch. It seems we have to stay with these then. Oh, but I should have remembered that. You cannot earn your certification running these locally. Fine. In that case, we continue with the third one. Celestial Bodies Database. This is one of the required projects. Oh, I think we are starting with the projects now. Build a Celestial Bodies Database. Cool. Yup. You'll build a database of celestial bodies using Postgres. Create a GitHub account. If you don't have one, you'll need it when you create the virtual Linux server machine. This process may take a few minutes. Complete both steps below to finish the challenge. Step 1. Complete the complete the user stories described in there and get all the tests to pass to finish step 1. Okay, after you pass all the project tests, save a dump of your database into a universe.sql file. So you can complete step 2. There will be instructions on how to do that within the virtual machine. Cool. Right, that's the first step. And then when you have completed the project, save all the required files into a public repository and submit the URL to it below. Required files, universe.sql, my GitHub repository and their files. Cool. Let us begin. Yep, I will be yawning, but don't worry. We will get through all of this soon enough. Yeah, I will have to wait for this to open. Code Road is opening now. This thing will also change its background color. Yep, that's what I figured. Those are the instructions. For this project, you need to log into Postgres with PSQL. Create a database. Do that by entering. I'm going to close this. Okay. Instructions. Okay. For this project, you need to log into PostgreSQL with PSQL to create your database. Do that by entering PSQL username freeCodeCamp DB name Postgres in the terminal. Make all the tests below to complete the project. Be sure to get creative and fun and have fun. Okay, let's first log in then. Yep, we are inside the project folder. As you can see, we have learned celestial bodies database in here. Yeah, let me much better, right? Okay, let's first log on. Yep, now we are inside Postgres. We can see we have 3 databases here. inside Postgres. Yeah, I'll keep yawning, of course. It's almost midnight anyway. But hey, we got to do what we got to do. Anyway, cool. So now we're logged in. Make all the tests below to pass the complete project. Be sure to get creative and have fun. Don't forget to connect your database after you create it. Yes. Thank you. Here's some ideas for the other column and table names. Description has life is spherical, age in millions of years, planet types, galaxy types, distance from Earth. Okay. Notes: if you leave your virtual machine, your database may not be saved. You can make a dump of it by entering. I will delete this. In a bash terminal, not the PSQL terminal. Acha. pg dump dash cc inserts this in a bash, not the PSQL. I think it will save the commands to rebuild your database in universe.sql. The file will be located where the command was entered. If there's anything inside the project folder, the file will be saved in the VM. You can rebuild the database by entering PSQL u Postgres universe SQL in a terminal where the .sql file is. If you are saving your progress on freeCodeCamp.org after getting all the tests to pass, follow the instructions above to save a dump of your database. Save the universe.sql file in a public repository and submit the URL. Yeah, cool. Complete the tasks below. We have a bunch of tasks. Good. Let's go through them one by one. You should create a database named universe. Okay. New database. So create database called universe. Database has been created. Done. Yeah. Be sure to connect your database universe. Next. Then you should add tables named galaxy, star, planet and moon. Okay. Let's do that. Okay. So first connect to universe. We are now connected to database universe as freeCodeCamp user. Cool. Next, create tables named galaxy, star, planet and moon. Good. So create table. Right. ये सब नहीं है, बंद करो. Right. New tab, very good. Create I'm going to Google how to create multiple tables Postgres. Alter table, no. How to create tables in Postgres. Creating multiple tables. How to create multiple tables in one go. I'm trying to write a script using a loop such as for loop. Okay. Let's just look at create table then. Create table name, column 1. Acha, table constraints. अच्छा एक ही बना सकते हैं, one at a time maybe, no problem, fine. Create table. Galaxy have to be case sensitive. All of this needs to be case sensitive. Star, create table, star, then planet and moon. We have passed the second test now. Next, each table should have a primary key. Yes. Primary key in Postgres. Column 1 data type primary key. Yeah. Each primary key. What are we trying to create? Galaxy, star, planet, moon. ठीक है, यूनिवर्स में बनाया. कोई एग्जाम्पल तो दिखाओ. Celestial bodies, yeah, galaxy, star, planet, whatever. We have millions. Each table should have a primary key. Each primary key should automatically increment. Okay. Each table should have a name column. Finally. हर एक की प्राइमरी की बनानी. It's not foreign key or anything. Are we using foreign keys? You should use the int data type for at least 2 columns that are not a primary or foreign key. Each star should have a foreign key that represents one of the rows in galaxy. Yeah, because moon, planet, star, galaxy. Your database should have at least 5 tables. Each table should have at least. Okay, there are a bunch of stories. I don't think we should go one by one then. Be sure to connect with your database, and tables have been added. Now we have to understand. Each table should have a primary key. Okay. So basically one column, that's the primary key. Let's create IDs then. Galaxy ID, star ID, planet ID, and moon ID. So we'll add columns and we'll also call them primary key. And also name. Okay. Alter table. So that's how you do it. Name of the column, type, and whatever it's primary and no null. Yep, we'll make it primary and I'll make it not null. Alter table first. Galaxy, add column, galaxy ID. You say primary key. Okay, but first we write the type. It will be integer, not null. Primary key. Is that allowed, or will there be errors? So one table has a primary key now. Each primary key should automatically increment. We only have one yet, so yeah, this passed. None of them passed. Acha. Each primary column should follow the naming convention. सही है. Moon table should have the primary key column named moon ID. सही है ना? मैंने सोच के बिना लिखा. But I followed the previous project's experience. Cool. Each table should have a primary key. Let's create that for all of them then. Galaxy, then star, Oh, sorry. Star. Done. Planet. And moon. Let's run the tests. Now 1, 2, 3, 4 are done, and this one is also done. Each primary key column should follow the naming convention table name underscore id. So moon underscore id, yeah, this underscore id, cool. So now we have them, and they're all not null, so they will automatically increment. Each table should have a name column. Is it possible to add column to multiple tables simultaneously? You probably need something like this. Arey baap re. Pura lamba code. How to add multiple columns in SQL? This is of course SQL. Post GRSQL. Add columns to a table. Babe, I know how to add columns. I want to add a single column to multiple in every table of a database. I have a database with 169 tables. I need this column in every table with WID integer, not null primary key. I tried this for the solution, but it didn't work on PostgreSQL. This was asked 8 years ago. So you want to add column WID in each and every table in your database? Yes sir, I don't want to do this by hand. The string concatenation operator in SQL is double. Acha, not a plus. Oh, you're running a for loop, are you? Aren't you? I do declare. Okay, just funny. Anyway, we go back. Okay, each table should have a name column. Fine. So we give each table a name column. You should use an data int type for at least 2 columns that are not a primary key or foreign key. Name will be a string, so where care will be used. Each star should have a foreign key that yeah, वो ठीक है, उस पे भी जाएंगे. All columns name should be of type varchar, exactly, and they will not be primary keys. Neither will they be not asked to be not null. So first varchar, let's keep it 40. Yeah, we create another called name, lowercase, table moon, add column name. All columns named name should be a type of varchar. Each table should have a name column. Cool. So first we go with moon, then star, then planet, then galaxy, in any order really. Done. Star, table has been altered. Planet, Galaxy, galaxy. Done. Let's look at our data now. Select from, wait, no, what's this look like? We have galaxy, moon, star, planet. They're all tables. Galaxy should have 2 columns, as you can see here. Galaxy ID and a name, character varying 40, nullable, not nullable, yes. The same will go for 1, 2, 3 and 4. Cool. Run the tests please. Each table should have a name column. Very good. You should use the int data type for at least 2 columns that are not primary or foreign key. What kind of data do we need? So does it say that anywhere? So these are some ideas. Description, has life, is spherical, that would be boolean, age in millions of years, planet types, galaxy types, distance from earth. Thank you. Yeah, I'll add description then. Description will also be varchar has life. That would also be, yes or no. In search of intelligent life. Is spherical, yes, no, again. Age in millions of years, yes, an integer. Planet types, galaxy types, yeah. Distance from Earth. What will be its distance from Earth? That's also an integer. Thank you. I'll add description, please. Can I do that? Galaxy, star, moon, planet. Is that allowed? Nope. Not allowed. Yeah, we'll need descriptions for each moon, each description, yeah, for each star. Cool. Star, moon, planet. Cool. You should use boolean data type on at least 2 columns. तो ये काम आएगा. Has life and is spherical. Yep. We do it. So you should, ऐसा करना है तो you should use the integer data type for at least 2 columns. Okay. Numeric data type at least once. Okay. You should use the text data type at least once. Oh, I should have given text data type to description then. How to change a column data type in Postgres. Alter table, alter column, set data. ठीक से दिखाना भाई को एग्जाम्पल दे. Postgres tutorial. Change column type. Syntax: alter table, the name of the table, alter column, column name, set data type, new data type. Example दिखाओ. Create table assets, id this, name whatever, insert into assets, name asset number whatever. इसमें वो कहाँ है? Now we will change the data type of the column varchar of the name column to varchar using the below statement. Alter table, alter column, name type varchar. अच्छा बस इतना ही. Table. Now we change the data type of the description and अच्छा. Alter column, location type varchar. अच्छा बस इतना ही. First we go to Galaxy. Let's make you text instead. Alter column, description, text. So there will at least be an X. Yeah. All columns named name. Yeah, that's okay. Each table. हाँ करते हैं. Text data type at least once. Yeah. Description will be given the text data type then. Error. At or near text. फिर से पढ़ते हैं. What does it do? First we write alter table, the name of the table, then we write alter column, then we write the name of the column. अच्छा हाँ तो alter column, description, and then you wrote a varchar. What was it before? It was varchar not null. Sorry, it was text not null. क्यों तकलीफ हुई उसको? PostgreSQL a text बस इतना लिखना ना. तो create table, id, serial, primary key, a text and b text. हाँ तो क्या तकलीफ है? Alter table, Galaxy, alter column, alter description, and you change this to text. Should I set this at 40 then? Or what? बंद करो इसको. Okay, it still says syntax error at or near text. Q. Parenthesis, then maybe only 40 characters. Postgres varchar to text. Created a column as varchar, but that is no longer sufficient. Either that varchar has no performance benefits over text on Postgres, so I'd like to convert the varchar to a text column in a safe way that preserves the data. Column 1, table 1, alter column, column 1, type text. मुझे type लिखना आता है. Wait, did I miss that? I missed type. Sorry. I did. Let's look at the syntax again. Alter table, the name of the table, alter column, then name, then type varchar. I will write text instead. Nice. We do the same for क्या था? Star. Done. Moon, planet, galaxy, star, moon and planet. Nicely done. Woo! If I run the tests, we should not have any problem. कहाँ गया text वाला? You should use the text data type at least once. Nice. Cool. You should use the int data type for at least 2 columns that are not a primary or foreign key. हाँ वो is has वाला यूज़ करते हैं. Has life is spherical. Yeah. Nope. Yeah, that would be a yes no thing. So we'll use boolean. Yeah. Has life or is and is spherical. Okay, let's begin. Planet, moon, ouch, planet, moon, star, galaxy. So yeah, as well as is spherical. Pherical. Is it spherical? Is it cake? Done. Moon, planet, और क्या था? Star. Nice. Run the tests, please. Okay, now we have boolean. Also boolean is taken care of. You should use int data type for at least 2 columns that are not primary or foreign key. Okay, that tells me. Let's look at all the columns we have so far. Moon ID, name, description, has life, is spherical. Okay, we already have one integer that are not a primary or अच्छा इससे अलावा भी 2 चाहिए. Yep, we can do that. What is numeric and what is integer? Between numeric and integer. If the data consists of only numbers like decimals, whole numbers, we call it numeric data. In numeric data, the number can be positive or negative. If the data consists of only whole numbers, it's called integer. Okay. Cool. We should use int for 2 more and numeric at least once. Numeric should probably be used for age in millions of years. And distance from Earth. What else can we use? What integers can we use? It's exhausting. Really? Think. What data can we set for celestial bodies? Let's say moon. Okay, let's think. Numeric data, we need numeric data too. I mean, yeah, age in millions of years. Done. Numeric data. Distance from Earth. Done. Okay. Cool, let's set up numeric data then. Age in millions of years. Alter table, star, add column age in millions of years. Numeric. Done. Add another to moon. Add another to planet. And the galaxy. Done. We should use the numeric data type at least once. That he's taken care of. We should use the int data type for at least 2 columns that are not primary or a foreign key. भी int का कुछ करना पड़ेगा. Anyway. Let it rain over me. We should use the int data type for at least 2 columns. हाँ, इन सबको फॉरेन की तो मैं बना दूंगा. ठीक है, चलो. प्राइमरी कीज मैंने बना दी नहीं. यस, ईच आईडी इज ए प्राइमरी की. ईच स्टार should have a foreign key that references one of the rows in galaxy. Each planet should have a foreign key. उस पे भी जाएंगे. First, let's finish all the columns with the corresponding data types so we can get started with adding data. At least 2 columns per table should not accept null values. So we need another not null. And I also need 2 int columns. Yeah, distance from Earth in kilometers. Right. Let it rain over me. Okay, another column to be added with the type int, not null. Null नहीं बनाना. What will this column be called? Gravitational pull would also be in decimals. What can I write? Think. World map, Greenland. I'm just reading. A moon. What can we write? That would be an integer, let's say between 1 and 1000 and whatever. Basically a whole number, not a float. Anything really. I can use really anything, so use your mind. Anything. We have galaxies. Galaxies would have a number of solar systems. Yeah. Then what? It wouldn't work that way, think. A galaxy, a moon, a planet. I can give them different as long as different columns have different values. I should make them unique then. But think. Moon. I was thinking of gravitational pull, but that would be. Yeah, distance from Earth it is then. Distance from Earth. That will only take care of, yeah, one column. We need another type for an integer as well. How do we get that? Alter table, moon, planet, and star. Distance from, oh, black hole. The one that surrounds our, the one that's, yeah, black hole that centers at the center of the universe. Supermassive black hole lies at the center of virtually all large galaxies in even our own Milky Way. Acha, supermassive black holes. Yeah, but that's inside a black hole. This wouldn't work with galaxies. Number of black holes. We'll see. Planet, star, moon, and galaxy. We are one to slouch, aren't we? Right, now we should have today integer type, at least two columns that are not a primary or a foreign key. Cool. Each star should have a foreign key. So now we go to the star tables, planet tables, the moon tables. A foreign key that references one of the rows in planet. That will only be known after we add some data to it. Your database should have at least 5 tables. Yeah, I think I'm going to take a short break, man. ये दिमाग फाड़ देता है मेरा काम कर करके. Yeah, don't worry, I won't go anywhere. I'll keep the laptop charged I'll be back in a couple of minutes. Thank you. I'll just fill some water and have some more coffee. Thank you. Yeah, let's see where we were up, what we were up to. Hmm. Okay. Yeah, I decided that we should first put some data in it to understand what the foreign key will be and how we'll connect them. A database should have at least 5 tables. Oh, eh? Oh, right. The progression. Yeah, that will be taken care of. We'll connect. Yeah, we'll have to connect them, right? Map them out. Each table should have at least 3 rows. Each table should have at least 3 rows. Yeah. Okay. Galaxy and star tables should each have at least 6 rows. Ah. Planet table should have at least 12 rows. The moon table should have at least 20 rows. Hmm. Yeah. Let's start adding some data to understand what we can give it. At least one column from each table should be required to be unique. This is new. Required to be unique. Okay. Ouch. क्या यार, ये पढ़ना चाहिए था. For that we need to look at the data again. So D, moon, anyone would matter, it doesn't matter. So not null is taken care of, integer is taken care of. What stories are we not finished with yet? Let's understand each of them. Each star should have a foreign key, foreign key, foreign key. Cool. Foreign key, yeah, mapping will take care of that. Each table should have at least 3 rows. Yeah, that will also be taken care of once we finish with the data. Finish adding a few rows, at least this many rows, and unique. Yeah, this is also pertaining to the foreign key. That's okay. At least one column from each table should be required to be unique. Let's say moon ID will be unique. No, the name will be unique. Let's make all the name characters unique. Yeah. So in that case, we use that type for this. Varchar. When did I change the type? Yeah, type text. So the name will be varchar 40, but it will now also be unique. Oh, so an alter table. Oh, sorry. You'll be moon and planet and whatever. This will become name. Alter column called name and set its type to varchar 40 and unique. It will be required to be unique. Is that allowed? No, there's a syntax error. Unique in PostgreSQL. So it's a constraint, right? ID serial primary unique, email varchar 50 unique. Okay, so it's better if we create another column that can be unique. Each table, a galaxy, then a moon, all moons, all planets. How do we get a unique character? Hmm. Okay, so we can write it this way or we can write it this way. First, insert a new into the person using insert statement. Second, insert with another duplicate mail. It will return an error message. Right. Hmm. So we need to add a unique constraint to another uh, column then. We can make distance from Earth unique or number of distance from Earth will be unique for each value, wouldn't it? Has to be. Yep. So distance from Earth, alter table, alter column, distance from Earth. We change its type to, so we keep it integer, but we also give it a constraint called unique. Is that allowed? That is not allowed. At or near, not. Okay, constraint error, syntax error. I think we can either make it not null or unique. Not null would ensure that it is unique or not. Fine. We create a new tables then. Email varchar 50 and unique. Okay, I can't use email of course, obviously. What can I write? Distance from Earth would be unique. Although I'll be right back. I'm doing something in the background. You guys may not be able to see it, but my mouse will be moving. Just a second. Right. Yeah, I'm just fatigued, nothing else. Is fatigue causing me to not think? What can we do about that then? What unique category can we give it? Maybe I can read this to understand again. Description, age in millions of years. Oh yeah, planet types, galaxy types. Oh, but it would be different. It would be a category, planet type, category type. Yeah. Maybe we can apply something else for each of them then. A column that has a unique value. What would be, let's say, a unique value for a galaxy? Number of solar systems for a galaxy, let's say. Yeah, I need some astronomy language. Yeah. Think. It's not that we're not allowed to, but I want to understand. Okay, we'll Google it. Unique properties of different galaxies. In PostgreSQL. I saw that. Anyway. Luminosity, population of stars, interstellar matter. Nice. So these are the properties of a galaxy. Maybe galaxies are astronomy mass to light. Galaxies parameterized by mass to light ratios. The luminous parts of galaxies with active star formation typically have mass to light ratios in the range of 1 to 10. The luminous parts of elliptical galaxies, which contain only stars, typically have a mass to light ratios of 10 to 20. It is still between a range. Properties of galaxies: Hubble, type, size, color, surface, brightness. 14 major properties of galaxies in new galaxy classification system. Properties are considered including Hubble type, size, color, surface, brightness. Surface brightness of Andromeda 22.3. Okay. A numeric value of Milky Way, I only know 2, I think. It's 20.202. That leads me to believe we can maybe use that for galaxies. Surface brightness, it will be numeric and unique. Yes, allowed. It is allowed. Alter table, add column. Cool. So that's for galaxies. Properties of, we have galaxies, planets. What are 5 characteristics of planets? It must orbit the sun. It does not orbit another planet. This means that it must not be a satellite. It must have sufficient mass. It must assume a nearly round shape. What are 4 types of planets? Gas giant, super Earth. Yeah. But we have several of same. Radius, yeah. Yeah, we can get unique radius values. Integer radius, radius planet. Is it planet or planets? I think we used planets. Planet, yeah. Moon, planet, whatever. Okay. Alter table planet, add column radius, integer unique. Cool. Then a moon. What do we call that it's revolving around? That it is revolving around. Moon. Parent planet. Host planet. Yep, host planet. Host planet. First, that means I have to find a host planet. Instead of a hyphen, I'll use an underscore. Alter table moon host planet. This will be varchar. Yeah, 30 should do it. Not many. Yeah, not much. Is nothing more than that. Alter table moon and add column host planet. So galaxy, planet, moon, and a star. Done. Properties of stars: temperature, brightness, luminosity, size, mass. Luminosity, then what is the name of our sun? Sol. But yeah, this is general use. We call it the sun apparently. Age. We already gave each item in age. Age in millions of years. As in sanctioned an official name for our sun. Are you kidding me? Ethanol technological. Why? Who knows? Yeah, we never know. Sol is its name in Latin, whatever. G-type main sequence star. Yellow dwarf. Though its light is actually white. What was I looking for again? Luminosity. The sun's luminosity is 1L, this whatever character it is. A 3D model of the sun from NASA. Photosphere, chromosphere. I'm not sure if I would be able to write that. I could be able to write 1L. So maybe not a property. Gravity. The sun's gravity 274 meter per second square. Yeah. Each planet would have its gravity. That's what I was thinking. For moon. अच्छा moon के लिए कर दिया ना. Star. Bard, give me a list of stars from every solar system in the Milky Way. Alpha Centauri 1 is a G-type main sequence. It's about 1.3 times the mass. How many did it list? This many. Right. Tell me their gravity. I don't know if that is a good question, a correct way to ask that question. Cool. 2.1 times 1.6 0. This times, and I can also export this to a sheet. Yeah, I was thinking of doing something. Write the commands to create this sheet / table in PostgreSQL. Anyway, we get it 0.03, 0.003. Yeah, we get the unique values now for a star. What do you call it? Gravity. Galaxy, planet, moon, star. Gravity. We'll keep it numeric. And unique. Yep. Star name, mass. For example, to create the table in my, you would need to type the following PSQL prompt. Create table star gravity, star name, varchar 50 not null, float not null, float not null. Oh, we can use float apparently. In my DB. Nice. Right, let's finish this. Cool. That has been added now. Let's run our commands one more time. What have we finished so far? So foreign key, then 5 tables. Yeah, that will be taken care of. Each table should have at least 3 rows. Rows, okay. And foreign key now taken care of. Cool. Let's look at our data now. Select asterisk from moon. Yep, the moon has these values. /d space moon. Yep, so it has these values plus a primary key and a unique constraint for host planet in moon. Let's start adding some data then. To add data we use insert into. Well, let's first go with all the moons we can think of. Give me a unique list of moons. Insert into moon. What do we need? The moon's ID, its name, its description, it has life, it's spherical. Oh yeah, we need to give that private key first. Sorry, foreign key. Why? Or we can give it no. Yeah, it will get very difficult. Think. Oh god. I have to wash my face. I'll fall asleep while doing this. Sorry. I'll be right back. I know I keep taking many breaks, but trust me, yeah, this will be much better. I'll wash my face and I'll be right back. Thank you. And I'm back. Sorry about that. Just extremely tired, I suppose. I am. Hmm. क्या करेंगे? Yeah, let's try and finish this. कितने 2 बज गए हैं ना? Yeah, I think I'll be going to finish this up. Let's try and add some data to Moon. What was I thinking before I started with this? Should have a foreign key that references one of the rows in galaxy. It means I think we can use host planet to connect the two. So we can use foreign. No, I'll have to create a foreign key. Let's understand this. Each star should have a foreign key that references one of the rows in the galaxy. So which galaxy it is in, let's say which star, which galaxy it is in. Cool. So galaxy ID in star. One of the rows in galaxy. What? Each star should have a foreign key that references one of the rows in galaxy. Let's try to understand that. Each star should have a foreign key. Okay. As in a star table with a foreign key that references one of the rows in galaxy. What do you mean one of the rows? Don't you mean one of the columns? Oh, each star is in each entry of the star table. Should have a foreign key that references one of the rows in galaxy. Oh. So, yeah, where the star is in the galaxy, which galaxy is that star a part of? We need a foreign key. And a column for that. So many columns. Right. Then each planet should have a foreign key that references. Yeah, because one planet would circle a star. Revolve around a star. Each moon would revolve around a planet. Yeah. Makes sense. Ding ding. Ding ding ding. Yeah, 5 tables बाद में each table should have at least 3 rows. वो सब भी डाल देंगे. Let's chill. First we need to figure out these columns. Each star. Let's go by the stars then. Alter table star. Add column. Foreign key. Yeah, we write this. Foreign key. What will be the column? It will be called star would have the galaxy underscore ID. They're all integers. Key. Oh, we just write FOREIGN, foreign key. Should work, might work, I don't know, it might or might not work. So we need to reference the foreign key too. right? Or no? Exactly. Foreign key in PostgreSQL. Foreign key columns. Okay. रेफरेंसेस, हाँ उसका रेफरेंसेस होगा ना. क्रिएट टेबल. कूल. वेयर इज़ फॉरेन की कस्टमर आईडी ऐसे लिखते हैं. अच्छा है. कंस्ट्रेंट नेम फॉरेन की. एक सिंटैक्स ऐसे है ना. Alter table star, add column galaxy ID, int foreign key galaxy ID. Syntax error. freeCodeCamp. Add constraint fk. Oh, by the way, we don't have that next val 2. How's that working out? No next val. Huh. Right. Foreign key constraints fk. Foreign key. References galaxy ID. Yes, syntax example, thank you. Show index from student Google. ओहो. बे फॉरेन की कहाँ है यहाँ पे. FOREI. अच्छा. Join from where is foreign here? Acha. And then make another query to add the foreign key to the column you made. It did not work. I don't know if I'm making a mistake. I used dit command alter table star add foreign key galaxy int references. Alter table star add foreign key galaxy id references galaxy id. Okay, that helps me. First I need to add that, don't I? So we've added a galaxy ID. Now okay, alter table. I can copy this. But I can't post fish. Alter table star new add foreign key galaxy underscore id references galaxy underscore id alter table star add foreign key error yep, done. Let's look at that. Foreign key has been added, so we should have this green line. Nothing yet. Fine, we'll do it later then. Galaxy, moon, planet, star. Nice. And databases, relations, we have those. Cool. List of tables. Galaxy, moon, planet, and star. Someone's trying to be very helpful with this guy. Oh, someone's coding in their phone. Wow. सही है. Okay. Yeah, my mind is not working. Yeah. Let's save this instead. Okay. You can make a dump of it in a bash terminal. It will save the commands to rebuild your database in Universe SQL. The file will be located where the command was entered if it's anything. Then in that case, thing inside the project. Let's try these steps. First I have to exit this thing. Then we write pg_dump space -c capital C hyphen inserts capital U freeCodeCamp universe .sql pg_dump cc inserts u freeCodeCamp universe.sql in a bash terminal on the PSQL1. It will save commands to your database. pq_dump error, connection to database failed, connection to server and socket failed, freeCodeCamp does not exist. Ouch. Universe exists in this. It is not. Where was the command written? pg_dump. It means in here. Untracked. The file was created. Eha. What? Are you kidding me? Are you kidding me, my friend? What? ये नया नया क्या क्या आता रहता है यार, दिमाग फाड़ दिया मेरा. What? What? This would have failed after I was finished. After I would have been finished with this, wouldn't it? PSQL-u Postgres UNIVRC. Is there a typo either? Maybe. pg_dump -c capital C then -inserts -u free अला freeCodeCamp लिखा है क्या अला freeCodeCamp. Done. It will save the commands to rebuild your database in Universe SQL. This file will be located where the command was entered, as in this. So if I write ls here, it will say universe.sql. Cool. If it's anything inside the folder, the folder will be saved in the VM. You can rebuild the database by entering, in a terminal where the SQL file is. Yep. Okay, so I have saved my progress, whatever I've built, even if it's nothing, but yeah, we're done. Exit. Okay, I'm going to close this. We will revisit this tomorrow, of course, again. Thank you for joining. कहाँ गया अला? Thank you for joining this live video. I will continue with the next live video in a few minutes, maybe 15-13 minutes, where I will read a book. So thank you for watching, thank you for joining. I'll see you guys in a couple of minutes. That thing is stuck now, aren't you? Wait a second, I just need to. Right. Anyway, yeah. I'll see you guys back in a couple of minutes. Thank you for watching. Thank you for your support. I'll be with you in a few minutes. Thank you. I mean, in the next live video.